Yes, dear students. So you can see that this is known as the structural formula. So now compared to methane in butane, we have got another formula which is known as the condensed formula. Now, if we really study in detail, we would realize, my dear students, that Lewis dot structure give detailed information. Detailed information. What we do not show electron, we don't show bond electron into the structural formula, but we show all the bonds. All bonds are present in the structural formula. But if you look into the condensed formula, we do not show bond much. And if required, we just show the carbon-carbon bonds, nothing else. Okay? So at least we do not show all bonds, we can write. And then in this molecular formula, we just show the number or ratio of atoms. So this has got the list information. I hope you understand, my dear students. Do you understand this? That, as we move, as we study the various types of formula, in Lewis dot structure we have more detailed information, but in the molecular formula we have the minimum information. That we just know about the ratio of the atoms, nothing much more about that. Now, my dear students, we want to study something else. I'll give you one more example to study. Let us study about benzene. The molecular formula of benzene is C6H6. We are not going to study its Lewis dot structures, but if we write the structure for benzene, we may have the structure of benzene in this manner. Please pay attention, everybody. Can you see the screen? Whatever I'm drawing, are you able to see?
Yes, sir.
Thank you. Thank you for the reply. Now, again you will find that this benzene has got the more than one type of structures, which we call it as a resonance structures. So now, my dear students, we are going to express benzene in some other manner. So this double bond has changed their position. You can see the changed position of the double bond. Once they were here and now they are here. But instead of showing this, my dear students, we sometimes show benzene in this manner. This manner, or we sometimes represent it in this manner. What does it mean? Why do we represent it in this way? So this is nothing but the same kind of representation, the same type of notation, same type of formula in which, my dear students, we do not show atoms. We do not show atoms. Now you can see that which atoms do we show into the formula, structural formula, carbon and hydrogen and all the atoms. Here we do not show atoms which are carbon and hydrogen. Please remember that in this type of representation, we do not show the atoms of carbon and hydrogen, but we show bonds. We show bonds. And that is why, my dear students, this type of representation, that is why, my dear students, this type of representation is known as bond line notation. Bond line notation. See, we have seen molecular formula, we have condensed formula, we have Lewis dot structures, we have structural formula. Now we have the fifth kind of representation of the molecule, which is known as the bond line notation. So in the 11th standard, we need to study in detail about the bond line notation too, my dear students. So now let us study about the bond line notation in detail, my dear students. But until now, if you have any doubt, you can ask me. बच्चों अगर अभी तक जो भी डिस्कशन हुआ उसमें अगर आपको कोई डाउट है तो आप लोग मुझसे पूछ सकते हैं. कोई डाउट है क्या?
No, sir.
तो चले आगे.
Yes, sir.
Okay.
Yes, sir.
Just a minute. So now, my dear students, we want to study about the bond line notation. Let us study about the bond line notation in detail. Bond line notation, that is what we are going to study about. Let us study about bond line notation. Suppose in bond line notation, I do one point. What is the meaning of this point? Can any of you tell me? What is the meaning of this point in bond line notation?
Close bond.
No, it is methane. Please remember, my dear students, that this point represents methane. Okay? Now suppose I draw the line this way. What is the meaning of it? Can any of you tell me? What does it mean? What does it represent? What is this? Can you tell me the name? आप लोग participate नहीं कर रहे हो. Come on, students.
Ethane.
Very good. This represents ethane. Suppose I show it this way. Can you tell me what is the meaning of it?
Ethine.
This is of course your
E-
CH3, CH2, CH3, which represents propane. Then if I do it this way, what does it mean? CH3, CH2, CH2 and CH3. What is this? Come on, speak up.
Butane.
Very good. It is butane. So have you noted something? Is there something comes in your mind about the bond line notation? Have you learned something? In bond line notation, how do we represent molecule? We represent
All.
very good. We represent molecular bonds in zigzag manner. See, if you do this, then you will not come to know it is butane. But you need to show that there are one carbon here, the another one is here, the another one is here, and the another one is here. That is how you represent the four carbon. First carbon, second carbon, third carbon, and fourth carbon. And that is why this zigzag manner is needed, that you represent the molecule in the zigzag manner. Understand the meaning of zigzag? You don't draw the straight line, but you represent it in the zigzag manner. Okay. We even represent double bond. Suppose I just do this. What does it mean? What is the meaning of this?
Double bond.
Butane.
Wake up, my dear students. Now you are in 11th standard. Please give some problem or give some pain to your brain. We have just shown the bonds, but then there must be carbon around it. So now can you tell me what is the name of this compound?
Pentane.
How come it pentane, my dear students?
Nine.
Ethene. Now we'll move forward. Suppose I show it this way. What do you understand from this? This is your CH2, CH, CH3. This is what it is known as your, and here you have the double bond. So this is what it is known as your propene. Now if I show something this way, see, try to learn, be aware, remain awakened. What do you understand by this? What is this? So it is your CH3, then you have the C, then again you have another CH3, then again you have another CH3 here, and here you have H. So you actually represent it in this manner: CH3, CH, CH3 and CH3. And you give it a name. Can you tell me what is the name of this compound? This is 1, this is 2, this is 3. 2-methyl. It is your 2-methyl propane. This is how you give the name. So till now, if you have, do you have any doubt? You can ask me, my dear students. Till now, if you could not understand anything, you can ask me.
No.
Understood everything, right? Good. Let's move forward and study something else. Suppose I have CH3OH, or if I have CH3CH2OH. This is what it is known as the ethanol. So my dear students, in the bondline notation, we do not show the carbon and hydrogen, but the other atoms, which are known as the heteroatom. Atom other than carbon and hydrogen are known as the heteroatoms. So please remember, my dear students, that we show these heteroatoms into the bondline notation. So suppose I want to write CH3, CH2OH, I would write it in this manner. Please pay attention. See, this is your CH3, then this is your CH2, and then I'll show OH in this manner. This is your ethanol. Suppose you have 2-propanol. 2-propanol. So your 2-propanol is in this manner. CH3, CH, CH3, and here OH. So that you will represent it in this manner. This is your 2-propanol. See, you need to understand, my dear students, this bondline notation, because in modern age, generally the bondline notation is used. Now, my dear students, suppose you have propanone. That is your CH3CO, CH3. So you will represent propanone in this manner. This is your propanone. So this is how, my dear students, you represent the various molecules or atoms into the different manner. Suppose you have this. Can you tell me what is this compound? Anyone? This is nothing but your, this is CH3, then here you have CH where you have Br, then you have CH2, and then you have CH3. So if we give the numbers in this manner, 1, 2, 3, 4. So simply it is 2-bromo-butane. This is how you understand. So now I think, my dear students, it is easy for you to understand. Even the cyclic compounds, we represent in this manner. So you know what is this? Can you tell me what is this? I have just explained you. What is the name of this compound? I have represented it with the bondline notation. Dear students, can you hear me? Correct.
Benzene.
Please repeat.
Benzene.
Benzene.
Very good.
Benzene.
Now in 10th standard you have studied about such compounds. Suppose I represent this, or if I draw this, or if I draw this. What do we call these compounds as? What names will we give to them? This is what it is known as. See, we have 3 carbon, 1, 2 and 3. So it is known as cyclopropane. This is what it is. We have 4 carbon, 1, 2, 3 and 4. So it is known as the cyclobutane. Here we have 5 carbon, 1, 2, 3, 4 and 5. So it is known as cyclopentane. Please understand, my dear students. Suppose we have this. There are no double bonds, only this. What do we call it? Can any one of you give me the answer? What do we call it? See, this is cyclopropane, this is cyclobutane, this is cyclopentane. What is this? At least any one of you can guess.
Cyclohexane.
Very good. It is known as cyclohexane. So this is how, my dear students, using the various bond-line notation, we can understand about the various compounds. Now I'm going to discuss some of the problems with you so that we can understand it better. Let us move forward and understand. Now we are going to solve some problems. My dear students, I am expecting the answers from you. So first we should look into the condensed formula. Suppose we are given some condensed formula. And we need to find out their structural formula. So let us move forward. The first question that we have is, you can try it in your notebook. CH3, CH2, CO, CH2, CH3. The next one that we have is CH3, CH, double bond CH, CH2, thrice CH3. We want to convert this into the complete structure formula. So what we'll do, we will first write the carbon. 1, 2, 3, 4 and 5. So I'm going to write 5 carbons. 1, 2, 3, 4 and 5. Now let me look at the number of hydrogen. So this carbon has got 3 hydrogen. This carbon has got 2 hydrogen. This carbon has got double bond O. This carbon has got 2 hydrogen and this carbon has got 3 hydrogen. And then I'll put this hydrogen all around and I will have the structural formula. The same way we can understand about this. Now please understand this condensed formula, that it has got how many carbon? 1, 2, 3. And then we have 3 CH2 continuously. That means 4, 5, 6. And then we have 7. So total we have 7 carbons. So we'll write all the 7 carbons. 1, 2, 3, 4, 5, 6 and 7 carbon. Then you can see that the last one has got 3. Here also the first one has got 3. This second and third have the double bond, and they have got each hydrogen, and then the middle 4, 5th and 6th have 2 hydrogen. So 2 hydrogen we can represent. And then we put all the hydrogens this way. So this is how, my dear students, we can get the complete structural formula from the condensed formula. Now, do you have any doubt? You can ask me. Now, my dear students,
No doubt.
okay, thank you. Now, my dear students, I'm going to write the formula here. From this formula, my dear students, we need to write the condensed formula. And then we shall write the bond line formula. Bond line formula or bond line notation. Whatever you find, you can call it. We can even call it as a bond line notation. Let us start with the first question, dear students. So the first question is this. You can start doing it in your notebook and then compare with the answers what I write. HO, CH2, 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 CH, then in the bracket there is CH3, then again CH, then in the bracket we have CH3, and then again we have CH3. So this is what it is, the first question. The another question is this, that I have N, then triple bond C, then CH, then again we have C, triple bond N, and then we have OH here. So these are the 2 questions. Now we shall write the condensed formula for them. So how we'll write the condensed formula? You can easily understand. For the first, we will write it this way. HO. Then we have 3 times CH2. So we will write CH2 thrice. Then, my dear students, we should write CH. And then we have CH3. And again we have CH. And then again we have CH3, but you can see that with this CH we have 2 CH3, so we will write CH3 twice. Now, my dear students, I need to explain this with the complete formula only. So I'll do it for you. You can see that we have first 3 carbon. This is 1, 2 and 3 carbon. Then this CH, I'm going to write it over here. So here we have CH, and below that we have CH3, then again we have, my dear students, CH, and then, or let me show the CH over here, and I'll write CH3 here, and then after this CH3, again we have CH3 over here. So that is what I can show you in the form of the bonds. This is CH3. These all are CH2. And at last we have OH. So if you really understand, my dear student, here, you will realize that this OH is represented over here. This CH2, these 3 CH2 are represented by CH2 thrice. Then, my dear students, this is CH. This CH3 is written in the bracket, which is not in the same line. Then again, this CH3 is also written in the bracket. You can see that this is the CH3 which is present over here. So this is CH and CH3, but again the next one is also CH3. So this CH has got 2 CH3. This is the first CH3. This is the CH3 number 1 and this is the CH3 number 2. So for this particular thing, we simply write CH and CH3 twice. So that is what I have written, CH, CH3 twice. This CH and CH3 and we have written separately. This 3 times CH2 and at last we have OH. So this is how we represent this particular compound. Now if we want to write the bond line notation for this, I need to remove few things. So that is what I am going to remove it for you. Okay. Now you can see that this is the OH. We will show the bonds and we will show the heteroatom. So what do we show here in the bond line notation? We show bonds and heteroatoms. Please remember, we do not show carbon and hydrogen in this. So here, my dear students, we shall write it in this manner, the bond line notation. First we will have HO. This is your HO. This HO is bonded to one carbon. So this is the first carbon with which the HO is bonded. Then we have the 3 carbon, this 1, 2 and 3 carbon. So this is the first carbon. This is the first carbon that we have. Then the second one. Then the third one. This is the third carbon. Then this third carbon is bonded with CH. So here we have, and then this CH is bonded with CH3. So for CH3, this CH, this is the fourth carbon. This is the fourth carbon which is bonded. See, this is one, first, second, third. This is fourth carbon. This fourth carbon is also bonded with CH3. So we have drawn this line. Then again we have the next one, next carbon. This is the fifth one. So here we have the fifth carbon. Then again it is bonded with another CH3. To represent the another CH3 we have shown this. And then again we have CH3 here. So this is the bond line notation. This is the fifth carbon, this is the sixth carbon that we show, and this is the here above. So both these are represented above and under that line. This is how we represent this compound. Now, my dear students, we are going to solve the next problem. Let's have a look to the next problem. Just 1 minute, dear students. Okay, now let's have a look to the next problem. We try to understand this N triple bond C. So this, when it comes to the writing the condensed formula, for this we will write the condensed formula as HO CH and CN twice. This is how we will write it. Now let us understand this. See, here you have HO. So this is what we have represented. Then we have this CH. And you can see that this CH is bonded with 2 CN. This is CN number 1 and this is CN number 2. So we will simply write that CN twice. So this is the condensed formula that we write. Now, dear students, we want to study about the bond line notation. In the bond line notation, we do not show the carbon and hydrogen, but when the carbon is bonded with the heteroatom, we will have to show it. And for that, we will show it in this manner. Please pay attention, dear students. You will enjoy this or you will like it. See, you have OH. This OH is bonded to the first number carbon. So here we have the first number carbon. And this first number carbon is bonded to 2 CN. So this CN, we will show it in the zigzag manner. And we will write CN. That's all. So this is how we write the condensed for the bond line notation for this compound. I hope my dear students, you understood it. Hello?
Yes,
Yes,
sir.
sir.
One more example I would like to share with you. Suppose we have this CH3, CH2, 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 CHO. This is what it is known as the 1, 2, 3, 4, 5 pentanol. So we will write the condensed formula as if CH3. How many times CH2? 3. So we will write CH2 3 CHO. But if we want to write the bond line notation, we will start from this first carbon. This is the first carbon. Then here we have second one, third one, fourth one, and fifth one. So first, second, third, fourth, and when we'll write fifth, we will write CHO. Please remember, my dear students, that when we'll write fifth, we'll write CHO. So this is how we represent the bond line notation for the pentane. So I hope, suppose if you want to represent the acetic acid, or instead of the this, suppose you want to represent the pentanoic acid. Let me save this to you for okay, let's move forward. Just 1 minute. Suppose you want to write about this acid, CH3, CH2, CH2, COOH. So the condensed formula, you will write CH3, CH2 twice, COOH. But the bond line notation, you will write it in this manner. This is the first carbon, this is the second carbon, third and fourth. First, second, third, and in the fourth, you need to write COOH. So this is how you write the butanoic acid. This is the condensed formula, this is the bond line notation. I hope it is understood, my dear students. Do you understand these or not?
Yes, sir.
Now,
Yes,
my
sir.
dear students, we want to study about the conversion of the bond line notation to the structural formula. So let us try to understand conversion of bond line notation or formula to the structural formula. So let me write the questions for you. This is the first question for you, my dear students. Now I'm going to do the second one. Then we have the third one to go do. Then we have the next one. Here are the questions for you, my dear students, and we need to solve them. So let us solve them one by one. What do you think by this? So please remember, my dear student, that they have just not shown the carbon and hydrogen. That is what we need to show it. So let me do it for you. See, this is the formula. Now what will I do? I will put all the carbons and hydrogen which is possible. So let me show you this way. See, this is carbon, 1, 2, then 3, then we have the fourth one, then we have the fifth one over here, sixth one, then we have a carbon over here, carbon over here, carbon over here. Now please remember that each carbon has got 4 valency. So this carbon has uses 1 and 2. So it will have 2 hydrogen. So you can see 2 hydrogen. Same way here also it will have 2 hydrogen. Here it will have 2 hydrogen. This will also have 2 hydrogen. But now look at this. It has used these 3 valencies. You can see that the first one, the second one and third one. All these are being used. So we will put only one hydrogen with it. Now even look at this carbon. This carbon has also utilized, see, this is first, this is second, and this is third. So here also we will put only one hydrogen with this carbon. But this carbon has utilized only one, so we can put 3 hydrogen around it. And here also we can put 3 hydrogen around it. And this is how we represent this molecule. अब अगर इसमें कुछ समझ में नहीं आया तो पूछ सकते हैं. If you could not understand anything into this, you can ask me, dear students. And if you do not have any doubt, let me know that you do not have any doubt.
No doubt, sir.
Okay. Now you can see the second question. There we have the 8 carbons. So we shall first draw all the carbons that we have. So we'll draw 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We have all 8 carbons with us. Now just we need to find out the valencies. So you can see that the first and the last carbon have utilized only one valency. Otherwise all the other carbons have utilized their 2 valencies. So the first and last carbon will have this hydrogen with them. 3. Otherwise all the other carbons will have 2 hydrogen.